Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. We have covered various data types in chapter 4, but in subsequent chapters I tried to use numeric data types to explain iteration statements and conditional statements. I think it is right time for us to take a pause and then have a closer look at the string data type. In this chapter, we will begin our discussion with some fundamentals of the string type. Later, we are going to have a look at some operations that can be performed on the variables of string type. So in that section, we will have a look at how to compare the strings, how to split the strings, how to concatenate the strings, how to dynamically form the contents of the strings, etc. While performing many of those operations, we need to pass a CultureInfo object. That's why we will also discuss few things about it. And finally, we will discuss one important question: when should we prefer StringBuilder type over string type? I hope you watch this video till the end, because like previous chapters, there will be some exercises at the end of this chapter too. You can try those exercises on your own to make sure that you have grasped all the contents from this chapter. So let's get started. Let's begin our discussion with a simple question. What is a string? We know few things about string type already. We have seen that a string is a reference type, so its value is stored on a heap. Similarly, we also have discussed about how to declare string variable. A sample declaration is shown here. It begins with string keyword followed by the variable name. The variable name can optionally be followed by an assignment operator followed by a string value inside double quotes. The string value inside the double quotes is sometimes called as string literal. Now let's see what is the technical definition of the string. According to technical definition, a string is a read-only sequence of characters. Here, the word read-only means that the characters in the string are read-only. We cannot modify them. There is one more important thing to highlight. In some programming languages, end of a string is marked by a null character. In C#, strings do not terminate by null character. In fact, a string can contain as many null characters as we want. Now let's see what are various ways to declare a string variable. The first line shows declaration without initialization. Here we have declared the variable, but we have not assigned any value to it. In this case, the default value is assigned to the variable, and the default value for string type is null. On the second line, we have declared a variable and we have explicitly assigned a null to it. Another way to initialize a string is using string.empty constant. As shown here, we can declare a string variable and we can assign string.empty value to it. Empty strings are different from nulls. When a string variable is assigned null, it means that the string variable is not pointing to any object on the heap. But when a string variable is assigned with a value string.empty, that means an object is created on the heap which doesn't contain any characters, and the string variable is pointing to that object. This string.empty constant is equivalent to specifying opening and closing double quote without specifying any characters between them. You also might have noticed one other important thing. Sometimes the data type name is beginning with an uppercase S, while in some other cases, the type name is beginning with lowercase s. An obvious question here is, what is the difference between these two types? Internally, both of these types are actually pointing to the same implementation. In .NET, string type is implemented using string class. The class name is string with an uppercase S. This class is defined inside system namespace. So when we use the data type name with an uppercase S, we actually mean to use that particular class. And for using that class, we also need to make sure that we have added a using statement to import the system namespace. C# has aliased the class System.String with the keyword string. The keyword actually begins with lowercase s character. So in a nutshell, the class name begins with uppercase s, while the keyword begins with lowercase s. Generally, it is recommended to use string keyword rather than the string class. Why? Because if you want to use string class, then you will have to add an additional using statement at the top to import the system namespace. But if you want to use the string keyword, you will not need the using statement. I hope the difference is clear now. Let's move on to the next way of declaring the string. We can also declare a string variable and initialize it with a string literal as shown here. Instead of using string keyword, we can use var keyword. In that case, the syntax is var keyword followed by the variable name followed by assignment operator followed by the string literal. When we use var keyword, it is mandatory that we initialize the variable with some value. This is because when we use var, the compiler needs to deduce the data type of that variable based on the expression on the right hand side of the assignment operator. If we use var keyword to declare a variable and we do not specify assignment operator and the expression on the right hand side, it results in compile time error. As we have seen in the technical definition, string basically can contain 0 or more characters. So we can create the string variable from the character array. In this code snippet, on last 2 lines, we have created a character array which contains 3 characters. And then on the last line, we have used new keyword to create the new string object and we have passed that character array as input. This new keyword is generally used to instantiate a class. We have not seen the details about this new keyword and we also have not discussed about the classes yet. So I will not discuss more about this particular method in this chapter. I hope you know various ways to declare strings now. We know that the string value is specified within double quotes. But what if we want to include double quotes inside the string? There is one example shown here. If we include double quote like this, then the compiler will give an error. It will say that the string literal is not well formed. So what can we do to include double quotes inside the string? Escape sequence is the answer. Escape sequence is basically a sequence of characters which does not represent itself, but actually that sequence is transformed into a single character. In C#, the escape sequence starts with a backslash character. So as shown here, if we want to include double quotes inside the string, then we can use this particular escape sequence which contains 2 characters, backslash and a double quote. These 2 characters will be converted into a single character inside the string, a double quote character. Similarly, if we want to include a single quote, then a backslash and a single quote is the escape sequence for it. Let's say if we want to add a null character in the string, then we can use backslash followed by a 0. These 2 characters will be converted into a null. Similarly, here we have shown some other important escape sequences. 3 important escape sequences are /r, /n and /t. /r is for carriage return, /n is for new line feed and /t is for tab character. If we use /r and /n, then the cursor will move to the next line for outputting the subsequent characters in the string. If we use /t, then it would basically render a tab character. Now, if we are using backslash for escape sequences, how should we include the backslash itself in the string? For including the backslash, it should also be escaped with another backslash. So 2 backslashes will be converted into a single backslash. As we know, in the .NET, the characters are represented by their Unicode values. The Unicode value can be a 16-bit value or a 32-bit value. Backslash and lowercase u combination must be followed by a 16-bit Unicode value. All of those letters will be converted to a single letter while outputting the data. On the other hand, backslash and uppercase u must be followed by a 32-bit Unicode value. All of those will be combined into a single character while outputting the string contents. I know this concept of escape sequences might sound confusing to some of us. Please bear with me until we complete the theory part of this chapter. Once the theory part is done, we will start with code examples where we will try to use these escape sequences to understand them better. We already have seen that the value specified within the double quotes is called as a string literal. C# supports 2 types of string literals, regular string literals and verbatim string literals. A regular string literal consists of 1 or more characters. It may contain simple characters as well as escape sequences. It may also contain hexadecimals and Unicode escape sequences. Before looking at what is verbatim string literals, let's understand what the word means. The word verbatim literally means in exactly same words as used originally. The verbatim string literal has @ prefix. The verbatim string literal also contains string value inside the double quotes. All the characters inside the double quotes are represented as is. A verbatim string literal will not process any escape sequence that appears between the delimiters of the string value. The only exception to this is double quote character. If we want to use double quote character inside verbatim string literal, then we can use 2 double quotes. 2 double quotes will be converted into a single double quote. A verbatim string literal may also span over multiple lines. Actually, after the compilation, verbatim string literals are converted into a regular string literals. But then the obvious question is, why should we use verbatim string literals? In my opinion, sometimes verbatim string literal usage helps to make the code more readable, and that's why they should be used. Now, let's discuss some commonly used string operations. Let's have a look at how to access individual characters from a given string. As we know, string is a read-only sequence of characters. It can contain 0 or more characters. So, it is a collection. And because it is a collection, we can use a for each statement to access individual characters. The variable declared inside the for each statement gets initialized with a single character from the string, and then that variable can be used for further processing. Once a particular iteration is over, that variable will be initialized with the next character from the given string. There is also one more way to access individual characters from a string. We can use integer index. In C#, the first character in the string is present at index 0, the second character is present at index 1, and so on. So if string contains 5 characters, then the last character will be present at index 4. So if we generalize this, the index of last character in the string can be found out by applying a formula string.length -1. So using this information, we can write any iteration statement to loop over string characters from index 0 until index is less than string.length. Here in this code snippet, we have used a for statement. In the initializer section, we have initialized index to 0. And in the condition section, we have specified a condition that index should be less than string.length. After every iteration, we want index to be incremented by 1. Then we can specify the index inside the square brackets to get the individual characters from the string. There is one point to note here. We cannot really modify individual characters from the string because string is a read-only sequence of characters. Now let's have a look at some other commonly used string operations. The code snippet here shows equality comparisons between two string variables. In order to check if the values of two string variables are equal, we can use equality comparison operator as shown here. For equality checks, we can use double equal to sign. If you remember, while talking about conditional statements, I told that double equal to operator behaves differently for reference types. For reference types, the double equal to sign compares references rather than comparing the actual values. This double equal to sign is overloaded in the string class to check for values rather than checking for references. And that's why this operator can be used to check if the values pointed by two string variables are equal or not. For the same reasons, we can use exclamation mark followed by equal to sign, the inequality operator, for asserting that two values are not equal. In addition to these two operators, the string class also provides one more method, equals, which can be used for checking if two values are equal or not. The syntax for calling equals method is first variable followed by dot followed by method name, and then inside the parentheses we can specify another variable or a value or an expression. So we have seen how to compare two string values for equality and inequality. Before we move any further, let's have a look at another important concept. As we know, string is a reference type. So a string object is created on the heap and its reference is stored on the stack. So when we declare two string variables with exact same values, then the compiler creates only one object on the heap. To better understand this, let's say we have two variables, x and y. Both are assigned with the same value. Also note that this value is known at the compile time. As the compiler knows that both of these variables are pointing to the same value, it will generate the code in such a way that when we run the program, only one object containing this value will be created on the heap. And then both of these variables will point to the same object, as shown in this diagram. This feature is called as string interning. String interning itself is a separate topic. I will not go into further details here. Then why did I bring it up here for the discussion? Because the string class also provides reference_equals method, which needs two parameters. Both of those parameters must be of string type. This method returns true if both of the parameters which were passed to the method are pointing to the same object. This means that both of those variables should have the same reference. The code snippet on this slide shows how to use reference_equals method. First, the code initializes two variables, first and second, with the same value. And then it calls string.ReferenceEquals to check if both of these variables are pointing to the same object. Because of string interning, they will point to the same object. And that's why the reference_equals method will return true and if block will be executed. If we want to avoid string interning, then we can use string.copy method to assign a value from one string variable to other string variable. So in this code snippet, we have declared a third variable which is also assigned with the same value. This time we have used string.copy method and we have passed the variable first. And after this, we have added code to check if the first variable and the third variable are pointing to the same object. Because string.copy prevents string interning, the reference_equals method will return false. And that's why if block will not be executed. Instead, the else block will be executed, which will print that first and third variable are not pointing to the same object. I hope the concept of reference equality is clear now. Let's move on. String formatting is another frequently used string operation. A format string is a string whose contents are determined dynamically at the runtime. There are two ways to perform string formatting: composite formatting and string interpolation. In composite formatting, string literal can contain some placeholders. Each placeholder is basically a number specified within the curly brackets. When the program is running, the placeholders are replaced by the actual values of the variables. There are many methods which support composite formatting. String.Format is one of the common methods that is used for this purpose. This method takes variable number of input parameters. The first parameter must be a string literal containing placeholders, and the subsequent parameters must be the variables whose values will be used to replace the placeholders at the runtime. The numbers that are used in the placeholders begin with 0. So the first placeholder will be 0 inside curly brackets, second placeholder will be 1 within curly brackets, and so on. The first parameter after the string literal will replace the first placeholder. The second parameter after the string literal will replace the second placeholder, and so on. In this code snippet, the first placeholder, which is 0 inside the curly bracket, will be replaced by the value of variable name. Another way to format string is interpolation. If we want to use interpolation, then the string literal must be prefixed with a $sign. Then the string literal can contain expressions inside the curly brackets. When the program executes, the curly bracket and the expression is replaced by the actual value of the expression. For example, the last line in this code snippet is a console.write line to print some data on the console. While printing the data on the console, instead of using composite formatting, it uses string interpolation. And that's why the string literal is prefixed with $sign. In the string literal, the variable is specified inside the curly brackets. When we run the program, the curly bracket and the variable itself will be replaced by the actual value of the variable. There are many other operations that can be performed on the strings. We can check if the string begins with a specific pattern or if it ends with a specific pattern. We can also check if string contains another string, or else sometimes we may want to modify the strings. We may want to convert all the characters from the string to uppercase, or otherwise we may want to convert all the characters from a given string to lowercase. Sometimes we may want to split a given string into multiple strings, while some other times we may want to concatenate multiple strings into a single one. Now that we know some basic concepts, it is right time for us to open Visual Studio and try coding some string operations. In the first code example, let's try to create a program to print string in reverse order. Let's begin with console.readLine to read the input string. Here, we do not want to store the reversed string in a variable. So, we can just access individual characters starting from the last character of the string until the first character and then print them. So, let's initialize loop variable index to string.length -1. Then we can write a while statement and we can specify condition that until this index is greater than or equal to 0, we want loop to continue. Inside the while block, we can access individual characters and display it on the console using console.write method. We have used console.write method here because we want all the characters to be printed on the same line, one after the other. After this, let's decrement the value of index variable by 1. Also, just before the loop begins, let's display a message stating that the output will be printed on the next line. Now, if we run the program, we can see that the strings are reversed. But when the program starts, the program does not display any text asking for input. It just waits until user provides input. It may be confusing sometimes, and hence it is better to add a console.write to display a message asking for user input. Now if we run the program again, we can see the instruction explicitly asking us to provide the input. If I provide any input here, the program will print the string in the reversed order. Okay, let's move on to the next example. Now, let's write another program which takes first name and last name as inputs. So, two console.read lines. First one reading the first name and the next one is reading the last name. While providing the inputs, user may enter white spaces before the names or after the names. And currently we are not interested in those leading and trailing white spaces. So, we can use trim method to remove leading and trailing white spaces from a variable. If we want to remove only leading white spaces, then we can use trim_start method. On the other hand, if we want to remove only trailing white spaces, then we can use trim_end method. The syntax is similar. Trim method also provides another overload. We can pass the character that we want to trim. So instead of white space, we can remove any leading and trailing characters by using trim methods. Okay, now let's try to concatenate first name and last name. Let's use string interpolation for that. The string literal will begin with a $sign, and then inside the double quotes, the expressions first name and last name will be present inside the curly brackets. We can also use two upper and two lower methods to modify the string contents. This method will return a string with all the characters converted to uppercase and lowercase respectively. Let's run the program, provide a sample input, and we can see that we are getting the expected outcomes. Now let's come back to the code. String class also provides two methods, StartsWith and EndsWith. These two methods can also be used to verify if the strings are beginning or ending with a specific pattern of characters. We can use a method StartsWith to check if a given string begins with a specific character or pattern of characters. Here, we can check if the first name is starting with whitespace character. If it is, then we are calling the trim start method to remove all the leading whitespaces. Similarly, there is another method EndsWith. This method can be used to check if a given string ends with specific character or pattern of characters. Let's add another if block to check if the last name is ending with whitespace character. If it is, then we can call trim_end method to remove all the trailing whitespaces. Let's run the program. Enter a lot of leading and trailing spaces for every input. We can see that the leading spaces are removed from the first name, and the trailing spaces should also have been removed from the last name. The trailing whitespaces from the first input and the leading whitespaces from the second input are still present. Okay, now let's move on to the next program. Let's write another program which takes a string input. This time, a string input is basically a comma-separated string which contains multiple names. So, a console.readLine to read the input. And now, if the given string contains comma, then we want to split the names and we want to print all the individual names on new lines. We can use contains method. This contains method takes a character or a string as a parameter. It returns true if the specified pattern is present in the given string. Let's add a if block, and then we can add a condition to check if the string contains comma, and if the comma is present, then this condition would be true and the control will go inside the if block. Now we want to split this given input into multiple names. For this purpose, we can use split method. Split method has multiple overloads. We are going to use the overload which takes a single character as input parameter. We will pass comma as the input parameter. This method returns string array. Now let's print all the items from this string array on the console. If we run the program, we can see that the program is printing individual names on the new line. But starting from second name, there are unwanted leading white spaces. So let's come back to the program and apply trim method. And now run the program again. This time, we are getting expected output and the leading white spaces are also gone. Now let's come back to program again. Instead of contains, we can also use another method indexOf. It takes a character as input and returns an integer value. This method returns index of the first occurrence of a given character. If the returned value is -1, then the provided character was not found in the given string. Let's use indexOf method to find the index of comma and then modify our if condition to, and let's say that when the index of the comma is not -1, then we want to print all the individual names on new lines. Now we can run the program and we can see that it has produced the same output as before. Let's move on to the next code sample. Next, let's write a program to extract a substring. A substring basically means a sequence of characters that appear in the given string. So let's declare a string variable and assign some value to it. String class provides a method with the same name, Substring. It has multiple overloads and we are going to use two variations of this method. In the first variation, we will call Substring method with a single input parameter. We will pass an integer value. This integer value is basically an index. This single parameter overload means that we want all the characters from the string starting from the index that we have passed as input. So if I specify 4 here, then excluding first 4 characters, all the remaining characters would be returned by this substring operation. While calling the substring method second time, let's pass two parameters. The first parameter here is the index and second parameter is basically a length, and we are passing 4 and 8 values. Here we are instructing substring method to return 8 characters starting from character present at index 4. Now let's run the program and we can see that the program is producing the expected outcome. Okay, let's move on to the next topic. We know that a string is basically a read-only sequence of characters, but many times we may need to modify the string contents. One of the options for that is to convert the string into a character array, and for that we can use toCharArray method. Once the character array is created, we can then access individual characters from this array and then modify them. Here, we have created a character array and then we are setting the second character of the string to a white space. Note that this change will affect only the character array. It will not affect the original string. So let's display this array on the console. Let's run the program and we can see that there is a white space after the first character. Okay, let's now have a look at how escape sequences can be used. Let's create a string variable and try to assign a file path to it. If I use single slashes, I get the errors. So now I can apply escape sequence. For every backslash that I need in the string literal, I am going to prefix it with another backslash. And now the program is not complaining. This is basically an example of a regular string literal. Another option is we can use verbatim string literal. So the string literal will be prefixed with @character. And then inside the double quotes, we do not need to escape the backslashes. Now let's say we want to print a famous movie quote on the console. I hope you have watched Kung Fu Panda. It is one of my favorite movies. Let's use a quote from that movie. You can see that we want to display double quotes as well on the console. One option to achieve this is to use regular string literal and then escape the double quotes by using backslashes. And then let's print the value. Another way is to use verbatim string literal. Inside verbatim string literal, we need to escape the double quotes. For every double quote that we want to show on console, we need to escape it with another double quote. So let's do that. Also, verbatim string literal can span over multiple lines, and all those new lines that I entered in the source code will also be printed on the console. Let's run the program now. We can see that the verbatim string is printed on multiple lines, while the regular string literal is printing the quote on the same line. Now, let's change our regular string literal to use a new line escape sequence. After every comma, let's add /n to add a new line. Now run the program again. We can see that even the regular string literal is printing the quote on multiple lines. I hope you found these code examples helpful. Let's move on. Generally, the strings are compared to answer one of these two questions. The first question is, are these two strings equal? And let's say if you have multiple strings, then the another question may be, in what sort order these strings should be placed when sorting them? The answer to these two questions are not simple. There are many factors that affect string comparisons. First important factor is which kind of comparison do we want to apply. We can choose either ordinal or linguistic comparison. Let's try to understand what is ordinal comparison. If we choose this method, then code will check two strings character by character while comparing their respective integer values are compared. And hence, this type of comparison is case sensitive by default. So if words are same but the casing of letters is different, then the default ordinal comparison will return false. We can of course change this behavior and ask our code to use case insensitive comparison. If we enable case insensitive comparison, then the two strings will be equal as long as they contain same characters regardless of casing of letters. The string equality operator, string inequality operator, and string.Equals method by default use ordinal case sensitive comparison. We already have seen how to use those operators in previous section. Now, let's say if we want to apply case insensitive ordinal comparison, then what should we do? For that, many methods provide additional overloads for comparing strings. For example, string.Equals method also has an additional overload which takes string comparison enum as a parameter. If we pass this additional parameter and if we set the value of string comparison parameter to string comparison.ordinal ignore case, then case insensitive ordinal comparison will be performed. This code snippet shows the example of ordinal case insensitive comparison. As we can see, string.Equals method has an additional parameter string comparison which is set to ordinal ignore case value. Let's have a look at what is linguistic comparison now. Linguistic comparisons are sometimes called as word sort order. In linguistic comparison, the strings are compared character by character. But while performing linguistic comparison, some non-alphanumeric characters may have certain weightage. For example, characters like underscores and hyphens may carry certain weightage in certain languages. And that's why if we try to apply sortings on set of strings, the sort order may change depending on the culture that was specified while comparing the strings. Also, sometimes a Unicode character may be a sequence of .NET Char instances. So in such cases, the platform on which your code is running may play a vital role in the comparisons. For example, you may have written code to sort multiple strings using linguistic comparison. The outcome produced by this program on Windows may not match to the outcome produced by the same program on Linux. This is because in linguistic comparison, some rules are platform dependent. Let's now see what the word culture means. There are various spoken languages all around the world. The same data might get represented in different format in those languages. Even if there are two regions which talk the same language, the data representation in those two regions may be different. Locale is the term for the information which is required to represent data in different language and regional formats. For representing data in different regional formats and language formats, we may need various kinds of information. That information should include which character is used as currency symbol. It should also include which characters are used as decimal point separator and thousand separators. It should also provide information about how the digits are grouped together in the numbers and in currency. Apart from this, the date and time formats may also be different in different languages and regions. Let's take few examples. The two cards here show the number, currency and date times format represented generally in US and Canada regions. EN-US is for USA while EN-CA is for Canada. Both of them are English-speaking countries. The decimal point character used by these two locales is also same, which is dot. The thousand separator is also same and the currency symbol is also same. But as we can see here, the date and time formats are actually different. In US, the date is represented in month followed by day followed by year format, while Canada uses year followed by month followed by date. The separator which separates different components of date are also different in these two cards. Now let's have a look at another two cards. The third card is for Great Britain, while the fourth card is for India. The currency symbols here are different. Great Britain uses pound symbol, while Indian locale uses Indian rupee symbol. Although thousand separator and decimal point separators are represented by same characters, the grouping of digits is not same. The same number 100k is represented differently on these two cards. Now let's open two more cards. The first card from the third column is how the same information is represented in German region, while the second card in third column is how the information is represented in Netherlands region. On both cards, comma is used as a decimal point separator, while dot is used as a thousand separator. This is different from all the previous cards. You might also have noticed that the currency symbol on the German card and currency symbol on Netherlands card, they are same, but the placement is actually different. The currency symbol is placed after the number on German card while the currency symbol is placed before the number on Netherlands card. There are also three other cards which shows how the same information is represented in Japanese, Thai and Chinese locale. This locale information is passed to string operations by using CultureInfo object. The CultureInfo object combines all regional settings together into one object. The settings include language, number formats, date time formats, currency symbols, etc. There are three different kinds of CultureInfo objects that are used very frequently. The first one is invariant culture. This means that both language and region is not specified. If invariant culture is used, then C# will use English as a language. For all the other settings, it will apply the defaults. Another way for passing CultureInfo object is neutral culture. In case of invariant culture, we don't specify both language as well as region. But in case of neutral culture, we can specify the language explicitly. We don't need to specify the region. Finally, we can specify culture explicitly by specifying both language as well as region. We can specify the culture names like EN-US, EN-GB, or EN-IN. These culture names are specified in ISO format. First two letters are for language and then hyphen followed by few more letters specifying the region. For example, when we specify EN-US as culture name, then EN is for English language and US is for the region United States. Similarly, when we specify EN-IN, then EN is for English and IN is for India. This CultureInfo object is basically an instance of CultureInfo class, and this class is part of System.Globalization namespace. So if we want to use CultureInfo class, we should have a using statement to import System.Globalization namespace. The code snippet here shows an example of how the CultureInfo class can be instantiated and how it can be used for comparing two strings. Here we have used string.Compare method. When we start execution of a program, it basically loads the default settings from the computer on which it is running. and all those settings are loaded as current culture of the program. We can also use that current culture object for performing string operations. I think we have enough information now about the cultures. So let's open Visual Studio and let's try to perform some culture specific string operations. Now let's write a program to compare the strings. Let's take name as input and let's check if this name is equal to John using equality operator. This time we are hard coding the value to be compared. If this condition is true, then display some message. After this if block, add another if block to check if this value is not equal to John. If it is not equal to John, then also display some message. And after this second if block, let's add another if block. This time we can use equals method to check if the input string is equal to the text John. All these three methods are comparing the input value with a hard-coded text. By default, it is ordinal comparison and it is case sensitive. So if I enter input John with lowercase j, then the second if block will display a message saying that I have not entered the expected name. Now let's try to convert this program to perform case insensitive comparison. For that, let's remove the first two if blocks and we can just use equals method. We can pass an additional parameter here in the equals method telling C# to ignore the case. And the parameter that we are going to pass is an enum value, string comparison dot ordinal ignore case. So the comparison is still ordinal, but the casing of letters is ignored. Let's run the program again and try to input the text John with lowercase j. Now even if the casing of letters is different, the program will correctly display the message that we have entered the expected input. Okay, let's write another program to sort the strings using ordinal comparison. Here we can declare a string array which contains 3 strings, and then we can call array.sort method which takes 2 parameters. The first parameter is basically the array that we want to sort, and the second parameter is basically a value from enum string comparer. We can specify this second value to use ordinal comparison. Let's run the program and we can see the sorted output. So we have seen how to sort the array which contains multiple strings. Now let's move on to the next example. Let's see how to use linguistic comparison. Let's declare 2 strings. This time we are going to use string.Compare method. The string.Compare method returns an integer value that indicates relative position of the strings in the sort order. If the returned value is less than 0, then the first string precedes the second one. And if the returned value is greater than 0, then the first string follows the second one in the sort order. On the other hand, if the returned value is exactly 0, then the 2 strings share the same position in the sort order. So based on this information, we will try to display a message telling the relative sort order of these 2 strings. Because we want to perform linguistic comparison, let's create a CultureInfo object. Here we are using new operator followed by the class name CultureInfo. And then inside the parenthesis, we can specify a string literal specifying the culture name, in this case en-us. For using CultureInfo class, we also need to add a using statement. So let's add using system.globalization at the top of the program. Now let's use this CultureInfo object for comparison. For that, we need to use overload from string.Compare, which takes 4 parameters as input. The first 2 parameters are basically 2 strings that we want to compare. And then the third parameter is basically a CultureInfo object. So we can pass the CultureInfo object that we have created. The fourth parameter is a value from enum compare options. This value is passed to customize the comparisons further. But we are currently not interested in it, so let's pass none. Then we can add multiple if conditions to display information about sort order positions of these 2 string values. Okay, our program is ready. Let's run the program and we can see that the output says first string is less than the second string. This means that if we use en-us culture, the first string will precede the second string in the sort order. Always remember that these linguistic comparisons are platform dependent. They may produce different results if we run this same program on different operating system. Okay, let's move on. As we have seen, there are various operations that can be performed on string variables. All these operations have been coded in such a way that they can produce the results efficiently. But we need to understand one thing. Strings are immutable. Now the word immutable is new. What does this mean? Let's say we declare a string variable and initialize it with some value. Let's say John. This will create an object on the heap which contains this value John. Later in the program, let's say we want to modify this value. Let's say we want to append the last name. In this case, instead of modifying the current object, a new object will be created on the heap and the reference on the stack will be changed. It will point to the new object. So when any modification happens on the string class does not modify existing object. Instead, it creates new object, and that's why string types are immutable. Now why are we talking about this behavior? Because let's say your program wants to perform many operations on a given string. In that case, every operation would result in creation of new object on the heap. So every step would require additional time to create new object on the heap and then changing the reference on the stack to point to the new object. We can certainly make this operation more efficient by avoiding creation of new object every time. But how? By using StringBuilder class. StringBuilder class is mutable. After we perform any operation on StringBuilder instance, it modifies the current object rather than creating new object on the heap. This code snippet shows how the StringBuilder class can be used. StringBuilder class is part of System.Text namespace. So we need to add a using statement to import that namespace. Then the code uses new keyword to instantiate the StringBuilder class. The syntax is variable name followed by assignment operator followed by new keyword, which is followed by class name StringBuilder. And then after the class name, inside parentheses, we can specify initial value that we want to assign to this StringBuilder instance. The StringBuilder class provides various methods which can be used for performing string operations. Here, in this code snippet, we have used two methods, append line and append. Append line adds a new line character to the string, while append method takes a string value as a parameter and this parameter value is then appended to the value of StringBuilder. Once all the intended operations are done, we can get the results into string variable by calling toString method on the StringBuilder instance. Now let's go back to Visual Studio. Let's write a program to reverse the string. We already have printed a given string in the reversed order. The logic is going to be similar, but this time we want string reversal to be done before displaying the output. This means we will need to iterate over all the characters in the reverse order and then append the characters to a new string variable. The new string variable can then be used to display the output. But we already know that performing too many modifications on a string type variable is not efficient. So instead of using string variable, we will use StringBuilder type for the target variable. Let's begin our program. Let's take a string as input and then run the loop from last character of the string till the first character. Until the index is greater than or equal to 0, we want to continue this loop. And then inside the while block, we can take current character pointed by the loop variable index. This current character can then be appended to the StringBuilder variable by using append method. This modification operation is not creating new object on the heap. It is modifying the existing StringBuilder object. After performing this append operation, decrement the index variable by 1. After all the iterations are done, we can take the StringBuilder value into a string variable. For that, we can call .toString method on the StringBuilder variable. This string variable can then be used to display the outcome. Let's run the program. Let's try to input any random string and our program prints that same string in the reversed order. Okay, that concludes this section. I hope you find these code examples helpful. Let's move on. Let's move on to the last section of this chapter. These are some exercises that you can try on your own. In the first exercise, you can ask user to provide a string input and then display the counts of vowels and consonants from that string. In the second exercise, ask user to input a sentence and then display the count of words in that particular sentence. In the third exercise, ask user to provide as many names as user wants. In single input, the names should be separated by comma. Then split that string into multiple so that each string contains a single name. Then sort that collection of names and then display it. In the fourth exercise, write a program to input a string. That string may contain all the unique characters or it may contain some duplicate characters. Modify that string in such a way that string contains only unique characters. Remove all the duplicate occurrences of all the characters so that end result should not contain any duplicate character in the string. And then display that outcome. Alright guys, that's it from this chapter. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.